All right, so this is the 13th problem in the grind 75. This is linked list cycle. We're given 20 minutes for this problem, and so we'll start the countdown now. All right, so given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. So internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. Okay, so I'm not really understanding that line. Pause is used to denote the index of the node that tail's next pointer is connected to. So say this is the head, the tail's next pointer. That's, I don't think we need to worry about pause at all. I'm just gonna see if that comes up anywhere. Pause equals 1, okay, well, maybe it is sort of important. So just so I fully understand it, it denotes the index of the node that tail's next pointer is connected to. Okay, so let's exactly see what they mean by this. The index, okay, it's 3, 2, 0, so 2. There's a cycle in the linked list. I'm looking at this example right here. There's a cycle in the linked list where the tail connects to the first node. Oh, I see. So the point at which the cycle, I guess, re-enters a node that it is already visited. So one, yeah, index 0 would be the pause. Pause. So we don't really have to worry about the pause. Oh, can you solve it in O of 1 constant memory? Hopefully, that would be awesome. So I know what the typical solution is to this kind of problem. It's two pointer. Actually, more specifically, it's fast and slow pointer. So slow will go will increment by 1 each time, and fast will increment by 2 each time. And they will eventually overlap. We can think about an example here. So they both start on 3, and then we have a point. You know what? Let me actually draw it out. Well, maybe I'll draw it out for the solution because I know that this approach works. So I'm actually just going to spend my time worrying about the implementation. So let's see. Basically, if they intercept, then we know there's a cycle. So if fast ever equals slow, return false. Let's see. So if we get through this whole thing and say we hit the end, then we know that there is no cycle. So, I think we can just worry about the fast pointer. So I will actually call .next twice for the fast pointer. I think that's pretty much how you have to do it anyways. You can't really skip over it. Well, you can do .next. But I will call it twice just to avoid null issues. So we're going to say, first off, if, well, how will we know exactly? I'm not going to account for linked lists of size 1, so I believe we shouldn't have to actually. But I'm going to start off by creating 2 pointers. They are both going to be initialized to the head, so slow is going to equal head. Fast is also going to equal head. And we're going to say while head is not equal null, we're going to push it forward. Head is going to be equal to head, well, not head. Fast is going to be equal to fast dot next. And this isn't really a great way of writing code, but the reason I'm doing this is so if, say, fast pointer, say this is a singly linked list right here, we don't have this pointer here. Fast pointer starts off on the head, goes 1, 2. Fast pointer goes here, goes 1, 2. But say fast pointer, it was an odd numbered linked list, so there was 5 elements, still singly linked with no cycles. We would go 1, 2, 1, 2, and then we would try to call. If we did this instead, .next, that would not work because we're at 5. Its .next is null, and null does not have a .next after that. So I'm going to do this, and at this point the while loop would terminate if we were on that 5th node in that singly linked list. But if that's not the case, then we still want to move the fast pointer 2 steps, and we want to move the slow pointer 1 step. Slow.next, and sorry, 1 second. The garbage truck just passed by. Anyways, so if slow.val is ever equal to fast.val, then we will want to return, what do we want to return? True if there is a cycle. True if there is a cycle. If we get through the whole thing, then we'll just return false. So this would take O of n time, where n is the length of the list, but it might even take more than that because the way the cycle works, some overlap will, the overlap will not really occur. Well, I would have to think through an example, but I know the fast pointer could theoretically go through the loop possibly a little over once, but the slow pointer should just intercept the fast pointer at some point. It doesn't necessarily have to be the length of the list, but I believe the runtime will be O of n. I am going to run this solution right here just to make sure we get it. And looks like the Wi-Fi has gone out actually. So give me 1 second. All right, internet's back on, so let's run the solution, see if it works. Let's see. Cannot read next. Okay, well, the while condition should be fast. Going to submit. Okay. I mean, this should terminate as soon as... Hmm. Let's see. So the timer has been going this whole time, but we still have about 10 minutes left or so. Null pointer exception. Yeah, because our input is this linked list right here. And we call next, but we're still within the while loop. So I was sort of iffy on this concept for a while. I was unsure if a while loop terminated as soon as its condition was false, or if it terminated once it got through everything in the body and then it checked the condition. So let's see. So can we say actually if fast.next does not equal null? Because that would require, if fast.next is null, then we wouldn't go there. If fast.next is not null, then we could end up there. So I will do that for the conditional. Just gonna run a test. That works. Let's submit. Okay, another null. Let's see. So if it's empty, we should return false, I believe. Right? So if head is equal to null, then we will return false. There is no cycle. So let's submit again. All right. So if slow.val is equal to fast.val, I see in this case fast will be null. So we can just check. We can do both, I guess. If slow does not equal null and fast does not equal null and slow.value equals fast. Okay. Should hopefully check every box. All right. Well, more null pointer. There's got to be a more concise way to write this, so I should be writing this first, actually. And this should be an and. So while fast does not equal null, and while fast.next does not equal null. Okay, just gonna hit submit again. Wrong answer. Okay. Well, so, okay, is that, how do we, okay, -1 means there is no cycle, right? So, as for the submission, wait. There is no cycle if there's a -1, return true. If there is a cycle, return false. expected false. So how did we get true? Oh, because the values are equal. Oh, so we have to account for not just the values can't be, if the values are the same, that's okay as long as they're not in the same position in the linked list. So that makes it a bit hard. I guess we didn't check the constraints. The number of nodes in the list ranges here. Is a valid index in a linked list. We also didn't get, if they are, so we sort of have to keep track of the position then. Position is not passed as a parameter. So we don't even care about the value. All we care about is the position, which we will have to keep track of ourselves. So that is a bit annoying. Also, if we have a cycle and we are keeping track of the position as we move through the linked list, but then we go through the cycle, how are we going to know that that node has this node right here too has that unique position? How are we going to keep track of that object specifically? So I guess we would need a tree map, or not a tree, well, a hash map to check if it's in there. So then if it is, we would technically only need to iterate 3 at once. And that would still be O of n. But what is this constraint down here? Constant memory. Yeah, I think that's actually, that would be the constant memory solution. So we add the physical node, the list node, to a hash map, and we have the value as its position. And it was sort of given to us in the problem there. So let's do that really quick. I am going to move this solution down here. We're going to comment it out, and we are going to take another go at this, give it another try. So we're going to create a hash map, and this is going to be a hash map of list node objects and integers, and it is going to be called, let's say, found nodes, or we can say visited nodes. This is going to be equal to just a new hash map. We're going to have the dynamic type be the same as the static type, and we are just going to make that empty. Can we see that? Yeah, we can. Okay. And we're just going to say, let's say we have a pointer head. Yeah. We don't really need another one. We can just move head on. So let's say while head does not equal null, we are going to check if visited, let's see, yeah, visited nodes dot contains head. If that's the case, then that means we've visited it before, and we want to return true, meaning that there is a cycle in the list. And is that all we have to do, actually? We have to move head on. So head is equal to head dot next. And am I accounting for any weird base cases? while head does not equal, okay, so we have to return false. Head does not equal null. Well, head does equal null, so then we would terminate in the case that we had an empty empty linked list. If we had a single element in our linked list, we would just add it to visited, move it on. Head would equal null, and then we would just return false here, add it to the hash map. So sorry, yeah, we forgot to add to the hash map. So visited nodes dot add, and we will put in head and the current index that we are at. So you can set counter out here. Oh, int counter is going to be equal to 0, and add counter plus equals plus equals 1. Head is equal to head. Next, move on to the visited. Okay, do we actually even need a counter though? Because we can just check if that physical object is in there. So we could just use a set. We don't even have to use a tree map, which makes things really easy actually. So can I just use set? I think I can just use set. New set type list node. Set type list node is in nodes. For sets, what do we do? I'm just going to look up the exact Java syntax for it really quick. Alright, so just a refresher on Java data structure syntax. So set is actually an interface. Hash set is actually an implementation of that interface. It's a class that extends it, or a class that implements it. And hash set has similar methods to hash map, so we can sort of essentially treat them the same when calling methods on them. So this should be right, head, and I'm just going to go over the logic one more time, but I believe it's right. So we're just going to have essentially a set of nodes. We don't need a counter, and all we're going to do is iterate through it, add it to our visited nodes, or sorry, I'm going to restart. So we have an empty set. We're going to start at the beginning of the linked list, and while our pointer, which is just going to be head, does not equal null, we're going to check to see if we have already visited it, and if we have, then we know that we found a cycle. Otherwise, we are going to add that node to our set, and we are going to increment our head pointer. If we get to the point where head is equal to null, or we've reached the end of the linked list, then we're going to return false, meaning that there was no cycle. And I believe this should be right. So I would submit, but the internet just went out again. So 1 second. Okay, we're going to hit submit, and let's see if we finally got it. Okay, did I? Yes, so need to do that there. Little syntactical issue. Of course, I'm missing a semicolon. Maybe I should just be running the test cases. Okay. Reached end. I believe, am I missing a? I'm missing a curly brace somewhere. So this one corresponds to what? Can I add one right here? Yeah. Okay, sorry. I'm just gonna run the test case really quick. That should work. Okay. And hit the solution, and yes, that works. Okay. That's a really nice, like very easy way actually of doing this rather than doing the two pointers. And that's even nicer because we can have a linked list with repeating values. So this is a solution I would present in the solution video, but I'll just make a quick separate video on that. But yeah, this has been the attempt for the 13th problem in the grind 75.